Swayam Prabha. Digital India. Educated India.
Welcome back to the course Mechanics of Solids. So, in the last lecture, if you recall, we talked about strain and strain in xy plane, okay? And if you know the strain components in xy plane, you can find out the strain components in other any arbitrary coordinate system like x prime, y prime and so on, right. So, and then we developed the equations from which we could conclude that for strain also you will be getting very similar to your I mean stress concept, you will be getting the Mohr circle of strain, from where you will be getting the strain components on some arbitrary coordinate system. Okay. So, now today what we are going to discuss, we are going to discuss about the measurement of strains, because we generally measure the strain. So, it is merely impossible to measure the stress directly. So, any body if you consider and if you apply some external forces on those on that body, basically that body, I mean of course, the body is deformable body and the body will show the deformation. So, we can measure the deformation, that is nothing but the strain, but we cannot specifically measure the stress directly. Okay. So, I mean once we measure the strain, right. So, I mean how we can get the information about the stress, that is the question, right. So, because stress is also required to be known. Now, what we do generally in mechanics, that we measure the strain for any system, any deformable body, and then we try to build or try to establish some constitution relation between stress and strain, okay, for any particular material. So, for every material you will be getting some constitutive relation that we can establish. So, by applying that constitutive relation and from the known magnitude of strain, we can find out the stress. So, that is a kind of back calculation, okay. And then you establish the correlation between stress and strain, and then you try to quantify the magnitude of stress. So, in that way we find out the stress. So, the measurement of strain is very important. Now, for that actually you have several say mechanisms or several say tools by which you can measure the strain. So, one of those mechanisms or tools, basically we I mean one important say tool is strain gauge. You might have heard this word several times in your professional career, right, strain gauge. So, by using the strain gauge we can measure the strain. Now, how the strain gauge works? Generally the strain gauge works I mean with the change in electrical resistance due to the mechanical deformation. Okay. So, if you have the mechanical say strain in the body, because that is the only thing we are going to find out, okay, and that mechanical strain will try to change or alter the electrical resistance of the strain gauge, and from there we get the signal, and that signal will be studied or analyzed by the signal processing unit, and then we will get the magnitude of strain. So, in that way strain gauge works. Okay. So, ultimately what we do, we fix the strain gauge along the direction of our interest, okay, and then after deformation we get the strain component say measured or I mean recorded by the strain gauge, and from there we can say that along this direction this much of strain has happened. Okay. Now, the important thing is that in case of plane strain, of course, we are talking about the plane strain condition. So, in case of plane strain, you know these are the three. So, if the strains are in xy say plane, so these are the three strain components are required to be obtained. right. So, two normal strain components epsilon x and epsilon y and one shear strain components gamma xy. But generally this strain gauge measures the normal strain, it cannot measure the shear strain. Okay. So, what we do generally, we measure the normal strain and from there in such a way, from there we can find out these three unknown components epsilon x, epsilon y and gamma xy. Okay. So, for that we measure three normal strain components, three normal strain components in three independent directions. Okay. Three normal strain components in three independent directions. So, along three independent directions if we consider in the xy plane, and along that we can fix the strain gauge, and the strain gauge will record the strain along those directions. Of course, those strains are normal strains. So, from these three normal strain components we can back calculate these values of epsilon x, epsilon y and gamma xy. So, once you know these values, then rest of the things are known to you. I mean, if you rotate any coordinate system and by this time you know how to find out the strain components in some arbitrary coordinate system. So, this kind of arrangement, now we will see that how we can arrange this kind of thing. So, suppose this is my xy plane. Okay. I have any three arbitrary directions we are just choosing, say this is my direction, say A, this is the direction say BB, and this is the direction say CC. Any arbitrary three directions we are choosing in xy plane. Okay, in the body we just mark xy plane and then we choose three independent directions. Okay, and these directions are defined by say theta 1, that means the direction AA plane is making an angle theta 1 with the x axis. Similarly, BB is making an angle theta 2 and CC is making an angle theta 3. Okay. And we are fixing the strain gauge. Okay. We are fixing the strain gauge along AA direction, BB direction and CC direction. So, three strain gauges we are putting and we are observing three normal strain components. Okay. Now, if we get three normal strain components from the strain gauge reading, then from there whatever equation we have developed for getting the strain components in some rotated coordinate system, say suppose now we are considering AA is one say arbitrary set of axis, BB is another set of arbitrary set of axis and CC is another set of arbitrary axis. So, if that is there, then already we have developed or we have derived this expression epsilon theta 1 can be written as in terms of epsilon x cos square theta 1. If you recall the previous lecture discussion, you will get it. So, epsilon y sin square theta 1 plus gamma xy sin theta 1 cos theta 1, right. Similarly, I can write epsilon theta 2 is equal to epsilon x cos square theta 2 plus epsilon y sin square theta 2 plus gamma xy sin theta 2 cos theta 2. Okay. And further you can write epsilon theta 3 is equal to epsilon x cos square theta 3 plus epsilon y sin square theta 3 and plus gamma xy sin theta 3 cos theta 3. I can write that. So, in the previous discussion, when we talked about this kind of equation, the left side was unknown. On the right hand side, you were knowing about epsilon x, epsilon y and gamma xy, and of course theta 1 was known to you, right. But in this case, you know the left hand side, because you are measuring, these are the measured strains from the strain gauge. So, epsilon theta 1, epsilon theta 2 and epsilon theta 3. So, these are the measured strains from different strain gauges, strain gauge A, strain gauge B and strain gauge C. Okay. And of course, you know, because you are choosing the independent orientation, independent say lines, right, A, B, B and C, C. So, these are arbitrary lines chosen by you only. So, of course, you know theta 1, theta 2, theta 3 and these 3 you are measuring. So, from these 3 simultaneous equations, you can find out these 3 unknowns, epsilon x, epsilon y and gamma xy. Okay. So, this is the idea, right, and this kind of arrangement is generally known as strain rosette. Okay. So, see this such arrangement is known as strain rosette. Okay. This is very important, because you whatever theory we are going to develop or we are studying, basically you need to get those observations from the experiment, right. So, from a deformable body you just measure the normal strains like this, like by putting the strain gauges, okay, in this fashion, and then from there you will be getting the information about epsilon x, epsilon y and gamma xy. So, once you know epsilon x, epsilon y and gamma xy, then rest of the informations like what will be the principal strains, what will be the maximum shear strain, what will be your strain components in some rotated coordinate system. So, all those information you will be getting immediately, right. And apart from that, once you know epsilon x, epsilon y and gamma xy, you establish some constitutive relation, okay, to get the stress components sigma x, sigma y and tau xy. So, that we will be doing later on. So, we will try to establish a relation between stress and strain. So, that we will do later on. Okay. I hope you have understood that what is the advantage of this strain rosette. Okay. Now, if you look at these equations, okay, these 3 equations, nowhere it is mentioned that, or you are not compelled to choose the magnitude of theta 1, theta 2, theta 3. So, you can choose as per your own choice. So, there is no compulsion that you have to take theta 1 value like this, theta 2 value is like that and theta 3 value like that. So, you are choosing theta 1, theta 2, theta 3 and accordingly you are placing or pasting the strain gauge. Okay. So, why do not we choose the values of theta 1, theta 2 and theta 3 in such a way that we will be getting or we will be minimizing the computational effort or computational calculations, right. So, you need to you need to minimize the computational calculation by choosing theta 1, theta 2 and theta 3 in such a way that your life will be simple. Okay. So, for that what people choose, people take generally two different types of strain rosette, that means two different types of arrangement. Okay. So, let us, so the first one is rectangular or 45-degree strain rosette. Okay. So, here what we do, we choose the value of theta 1 as 0 degree, theta 2 as 45 degree and theta 3 as 90 degree. So, these values we can choose, this is up to us. Okay. So, how it will look like then? So, this is your xy plane. Okay. Now, theta 1 is 0 degree, that means in the previous figure the line AA is coinciding with x axis, right. Okay, fine. So, line A is coinciding with x axis. Now, theta 2 is 45 degree, that means the line BB is making an angle 45 degree with x axis. So, that is here, this is your BB, this angle is 45 degree and theta 3 is 90 degree. The line CC is coinciding with y axis, then only it will be making an angle 90 degree with the x axis. So, this is your line CC, because these angles or the arrangement of the strain gauges is completely up to you, right, how you are choosing that. So, then why do not you take the advantage of your less computational effort. Okay. So, if you choose the axis like that, then basically your epsilon x, if you put theta 1 equal to 0, theta 2 equal to say 45 degree and theta 3 is equal to say 90 degree, and if you know these strain components, okay, from the strain gauge reading, then basically you can write epsilon x equal to epsilon 0 degree, epsilon 0 degree means epsilon theta 1, okay, epsilon y is equal to epsilon 90 degree, that means epsilon theta 3 and epsilon and gamma xy will be 2 epsilon 45 degree minus epsilon 0 degree plus epsilon 90 degree. So, you just simply measure these strain components from the strain gauge, okay. You get the reading, you put in this equation, you get epsilon x, epsilon 1, gamma x, and rest of the things you can calculate by your own, like by drawing the Mohr cycle or whatever. Okay. So, understood the concept. So, here now you see that by choosing the arrangement or the strain rosette, okay, by choosing the values of theta 1, theta 2 and theta 3, we have minimized our computational effort or computational say calculations, right. Otherwise, you can choose any value of theta 1, theta 2, theta 3, there is no compulsion. Okay. So, this is known as 45 degree strain rosette or rectangular strain rosette, and it is very, very popular, and most of the experimental analysis people try to follow this strain rosette, that is rectangular or 45 degree strain rosette. Now, similarly, another strain rosette is there, that is 60 degree strain rosette, known as equiangular or delta or 60° okay. In literature it is mentioned as equiangular or delta or say 60° strain rosette. Okay. So, here what we do, we choose the value of theta 1 as 0°, theta 2 as 60° and theta 3 as 120°. So, what we get, this is my xy plane. Okay. So, theta 1 is 0° means a line will be coinciding with x axis. So, that is fine. So, that is like this. So, this is your a line. Okay. Now, BB line will be making an angle 60° because theta 2 is 60° here. So, BB line will be making an angle 60° with x axis. This is your BB. And CC line will be making an angle 120° with x axis because theta 3 is 120. So, this is 60 and this is another 60. So, this is your CC. So, this is your 60° and this is your 120°. Okay. So, this is the arrangement. So, we will be placing the strain gauge, we will be placing the strain gauge like this. So, this is my strain gauge. So, we will be placing the strain gauge like that and then we will be measuring the strains. So, from there what we will get, so from there we can simply write epsilon x equal to epsilon 0°, epsilon y equal to twice of, that can be obtained from those three equations pretty simply, 60° plus 120° minus epsilon 0° by 3 and gamma xy can be obtained as twice of epsilon 60° minus epsilon 120° by root 3. Okay. So, you measure these things and then you get the strain components in xy coordinate system. Okay. So, I mean from the calculation you can get the strain components like that. Now, if you want to find out, at least for 45° strain rosette, if you want to find out the strain components from the Mohr circle, then we can construct the Mohr circle for 45° strain rosette. Now, let us see how we can construct the Mohr cycle for 45° strain rosette at least. Okay. So, now come back to this figure, get the process first, I mean how we can construct the Mohr circle for 45° strain rosette. So, we are choosing epsilon and gamma by 2 space, okay, which is required, which is very much required for your I mean Mohr cycle for strain. Now, we know epsilon A, epsilon B and from the strain gauge reading that we are measuring. Now, these things we are plotting, okay, in this space by drawing one, we are drawing 3 vertical lines, that means parallel to the gamma by 2 axis. We are drawing 3 vertical lines such that this line, the first line is epsilon A distance away from gamma by 2 axis. Similarly, the second, I mean this is the second line and this is the third line, and here we are just considering, I mean this is, I mean just from your reading whatever we are getting, as per that we are considering this situation This is the situation we are considering. Okay. Epsilon B is greater than epsilon C is greater than epsilon A. Suppose this kind of arrangement is coming from your strain gauge reading, then you are just dropping 3 verticals like this away from gamma by 2 axis, epsilon A distance away, epsilon C distance away and epsilon B distance away. Okay. Now, you look at point D, you look at point D in such a way that D is the midpoint between the strains which are making in 90-degree angle, like I mean epsilon A and epsilon C, right. So, I mean in the 45-degree strain rosette what is there? This is AA, this is CC and this is BB, right. This is my 45-degree strain rosette. Okay. So, this, so you choose a point, you locate the point D which is the midway between the 2 vertical lines representing the strains for the perpendicular axis A and C. So, perpendicular axis A and C are perpendicular. Okay. So, you locate the point D in such a way that that is the midway between point A and C, which are actually perpendicular axis in the coordinate system as shown here. Okay. So, once you locate point D, now you measure dB, you measure dB. Okay. Now, lay off AA, come to this figure, lay off AA and lay off CC, okay, on the vertical lines in such a way that AA is equal to dB, AA is equal to dB and CC is equal to dB. Okay. So, we are just choosing 2 points, point A small a and point small c. So, these 2 points we have got on these vertical lines. So, these are the vertical lines. On these vertical lines we are locating or we are laying off the distance AA and CC. Okay. So, after that what you are doing, then considering DA as the center, okay, DA or rather AC as the diameter, this as the diameter, okay, and D as the center, you complete the Mohr circle. So, this is your Mohr circle. Now, this Mohr circle is cutting the vertical line drawn at point B at small b point. Okay. Now, this point A, point B and point C basically are lying on the Mohr circle and they will be defining the A plane, B plane and C plane on which we can find out the strain components. Now, if you look at these triangles, I mean triangle DAA, okay, triangle DCC and triangle DBB. So, all these triangles are similar triangle, right, because 2 sides of these triangles are similar, because AA is equal to say DB is equal to CC. Similarly, this DB is equal to DC equal to DA, because they are the radius of the Mohr circle. So, these 3 triangles are similar triangle. Now, from this actually if you try to find out, now it is not necessary that because your strain gauge is measuring the strain, a normal strain, that does not mean that along that axis there will be no shear strain. I mean on that particular plane there will be no shear strain, you cannot say like that. Okay. So, that is very true from this figure. So, point A will be denoting plane A, right. That means this is the axis, this is the axis here. Point B will be denoting this axis and point C will be denoting this axis. Now, if you look at these points, point A, B and C on the Mohr circle, they are telling about epsilon A, epsilon B and epsilon C along with the shear strain. Okay. So, that we are not measuring, we are just because our strain gauge is capable to measure only the normal strain. Anyway, so that is different issue. Now, whether this Mohr cycle construction is right or not, because that is written here incorrect construction. Now, why it is incorrect? You need to find out that. Okay. So, I will stop here today. In the next class, we will take it again, so that we will understand why it is incorrect and what should be the correct construction. Okay. So, I will stop here today. Thank you very much.